developers need to do. That's going to take care of this problem. We're going to make them high assurance so that we take care of this chunk of problems. And then we're going to try and make it really easy for them to use it properly to take care of these problems. So that's sort of the goal of the project that we set out. All right, our goal really is to enable developers. What we found is that it's pretty hard to take all this knowledge in application security, and you can add the entire Owasp site to this page, if you will, and try and cram it into the developer's head. It's a lot. So I've spent pretty much my career focused on application security, and I still don't understand all of the problems that there are in application security. It's a very big space, and every single one of those problems is tricky. They're complicated to understand. So what we're going to try and do is we're going to try to enable developers with an API that does the stuff that they need to do. This is like communicating to the developers in their language, where you can use methods and parameters and stuff to talk to them. I think you also need a secure coding guideline to go along with the API. So you can't just hand them an API and say, go. You've got to give them a coding guideline that says, here's how you use this API to do the things that you need to do. And there may be some hands-on training involved to really teach them how to use it. But we think we can make this problem much simpler for developers. So let's talk about, so you might be thinking, well, I don't know, you're just one more library out there, right? Well, there's a problem with using, there's a bunch of security libraries out there, but there's some problems if you try to use those security libraries directly. So for instance, the Java cryptography extension, JCE, a lot of people use that for encryption. It's a great API, but it's what I call a bottom-up API, right? It does everything in encryption, right? It does encrypting and decrypting, but it also does a whole bunch of other stuff, like key generation and revocation and key stores and a whole bunch of things that most developers don't need. So we want to isolate all that complexity. In fact, I heard somebody call the JCE API encrypted. It's so hard to use. Right? So we want to isolate all that complexity from the developers. Most developers only need encrypt string and decrypt string. They don't need a whole bunch of super powerful, complicated crypto API. And it's the same for all these different libraries. So the libraries are overpowerful. In a lot of cases, they're also incomplete. They don't do all the things that an enterprise security developer needs to do in security. So we're trying to fill in some gaps. The fact that they're not integrated is a big problem. So you want all your security mechanisms to log stuff, right? That's how you're going to tell whether the security checks fail or don't fail. Unless all of these mechanisms use a common logging library, you're not going to get all the right output in the right place. So one thing we can do with ESAPI is we can tie all this stuff together and make it log right. It's the same thing with error handling and a few other things. We want to wrap all these libraries. And that's what ESAPI does. We're building on the shoulders of giants here. So I think of ESAPI as a top-down API. We start with what the developers really need from a security perspective, and then we implement those methods with all this powerful stuff that exists out there. Oh, one other problem I wanted to mention is if you build your applications to these libraries, it becomes extremely difficult to change to another technology if you decide you want to, right? So if you build all your applications to Log4j or JCE directly, and then there's some problem with that, or you want to change to a different one, it's very difficult to rip all that out and replace it with a new engine. With ESAPI, you get a layer, sort of an abstraction layer, that will allow you to change this stuff out. All right, so here is ESAPI. You can see at the top you've got your custom web application code. It talks directly to ESAPI. And then there's a bunch of different classes. This covers what we think most enterprise developers need from a security perspective. So there's authentication and a user object for identity management. There's an access controller. There's something called an access reference map that I'm going to talk about a little bit. Validation and encoding, and built in here is canonicalization. I'll talk some about that too. I've got a bunch of HTTP utilities to augment some of the weaknesses in HTTP. There's encryption and encrypted properties to store sensitive information. There's strong random number generation. Security exception handling, we've put in some support for that. We've got a logger. We've got some intrusion detection. The intrusion detector is here where we're sort of going beyond the state of the art here. And I'll talk a little bit about how this stuff works. And then all the security configuration is managed in one place. So you can actually audit it and see what changes from one release to the next. So we've tried to capture sort of the scope of what you would need in an enterprise application. And you can build that on top of your existing enterprise security services. So we know that we can't provide a one-size-fits-all library for everybody, right? You know, you're probably talking to DB2, you're talking to Oracle, other people are going to talk to their own authentication infrastructure, and so on. So what we've done is we've created this API of interfaces. There's different languages involved, but I'm going to talk about Java because that's the one that's sort of farthest along. So there's a bunch of interfaces that you can implement to, or you can use the full reference implementation that comes along with this that gives you an example of how to implement this. Okay. So you wouldn't really have to implement a lot of this stuff. Really, I think the main places where you'd have to extend this are in authentication and probably in access control a little bit, and then maybe in logging. You'd need to tie it into your logging infrastructure. But otherwise, you can probably stick with the reference implementation for things if you don't have an existing capability. OK, so let me talk through a couple examples of how ESAPI works. This is probably the best way to get your head around what's going on here. So let's talk about input validation a little bit. So I don't expect you to be able to read this, but what this is a list of of some of the different ways of encoding the less than sign that are valid in a web page in some particular context. So we've got some percent encoding, we've got HTML entity encoding, a bunch of different forms. There's JavaScript escaping, there's CSS escaping. All these different syntaxes are valid in some part of an HTML page. Over here are recipes for double encoding. There are certain ways to encode characters using two different kinds of encodings at the same time, and it really makes a combinatorial explosion. Like you could take these double encoding techniques and apply it to any of these, and you're going to result in hundreds of thousands of different possible representations of a less than sign that are valid in some particular web page. This is the problem that people have to deal with when they're validating input on the web. You have to say that input is valid in any of these possible encodings. This is a very tricky problem. Here's an example of some of the kinds of double encoding that I'm talking about. You can see over here we've got the original, which is double encoded in some way. In this case, it's percent encoding and HTML entity encoding. If you decode it first with HTML entity encoding, you get this, and then you do a URL decode and you get this, which is safe. But if you do it in the other order, if you do the URL decoding first, and then the HTML entity decoding, then you get a less than sign, which is potentially dangerous. This is an extremely difficult problem. There's a few more examples here that I won't go through, but suffice it to say that you have to canonicalize before you do input validation. Everyone always says that, but no one does it because nobody knows how to do it. So we've taken a stab at actually doing it in ESAPI. We've got a pretty cool design, I think. The way it works here is when you get input from the user, you get into your application, and you call the validator when you need to use that data. You call the validation engine, and there's a bunch of methods available to validate your input. So if you've got a credit card number, you've got some other kind of input that you've defined in a regex, it's very configurable. But you can get safe content back from the validator. Underneath the hood, the validator calls a decoding engine and decodes the data with a bunch of different decoders, and it handles double encoding. So I think this is beyond the state of what I've seen, at least in my experience, of what's out there for handling input validation. So if anybody says, hey, we've got this great input validation library, just ask them, how do you handle canonicalization? Because this stuff is really hard. So this all happens under the hood. A couple of cool things that are going on over here. We've got this get valid safe HTML call. That's layered on top of the anti-SAMI library, which I mentioned this morning. It's for when you have to accept HTML into your into your site and then render it as part of web pages, like if you're a MySpace or an eBay, like Robert Hansen was talking about a few minutes ago. What that call does is it returns you a safe version of that HTML. It parses the HTML, strips out any tags according to a configurable policy, and returns you a safe version that won't have scripting attacks in it. So that's cool, and there's a nice, easy API to that in ESAPI. There's a few other things. There's a safe readline function to replace Java's broken readline function that can read forever and cause an out-of-memory exception, take down your VM, a few things like that. OK, so that's input validation. We've got a nice engine here. The next thing I want to talk about is output encoding. And to do this, I need you to understand that inside a web page, there are a bunch of different execution contexts. The typical one that you think of is sort of inside a JavaScript block. But you can also put code inside a CSS page or inside an HTML attribute, like an event handler. You can put it in a URI. There's lots of different places where code can go inside a web page. And each one has different encoding rules. So that advice that you see in your best practices document that says always use HTML entity encoding before you put something in a web page, well, it's a good idea, but it's not quite accurate. You need to use the right encoding for the places that this data will land in the web page. So for CSS, you need to do this kind of encoding. For JavaScript, there's a slight variation of that. It's a different parser. It needs a different escape syntax. Same thing for elements and attributes. Event handlers all have a different encoding style. So you need to have a set of encoding methods that you tell your developers, use this encoding method for this particular HTML context. That's the way to prevent scripting attacks in web pages. So we've got a nice library of these in ESAPI. There's this encoding engine that I talked about. There's a set of codecs that implement these different formats. And it's fairly straightforward to use. In your presentation layer, you simply call the appropriate encoding method for the context that you're putting the data into. There are also encoders for other things. There's encoders for SQL, encoders for LDAP, encoders for other back-end systems that you need to encode output for. So the idea here is that we can prevent all injection attacks using the encoder. Someone actually pointed out to me that you can encode for different operating systems. So in Windows, there's an escape character. In Unix, there's a different escape character. So now we have encode for execution purposes as well built into ESAPI, if you're calling the native operating system. So that's output encoding. Let's talk about authentication. This is a tough area for developers. They've got to write a lot of custom code to handle this. What we've tried to do is simplify this down to where it's very easy. So essentially what the developer has to do is call login on any page where, on any flow, like in the controller or any other flow where he expects the user to be logged in. And then anywhere else in the application, he can ask for the user object and get a hold of the currently logged in user. Now that's used under the hood in a number of places. That's used in the access control checker. It's used in the logger. So all those things have access to the user object sort of throughout the application. So we've dramatically simplified the way that you handle authentication within an application. So compare it to if you didn't have this. If you didn't have this, you end up having to pass around the session or some other way of conveying the currently logged in user all throughout your application. With ESAPI, you can just get the user from wherever you want. So there's a lot of complexity lost here. There are also a bunch of supporting methods that we've provided to do things that people want to do related to authentication. You can do encrypted cookies very easily with the API. There's CSRF tokens built in, so it's fairly easy to implement that. You can do things like change your session ID. Java actually has no provision for changing your session ID, but it's something that every web application should do. When you go from unauthenticated to authenticated, you need to change your session ID so that the attacker can't use the session ID that you exposed before you authenticated. So we got a simple provision in here that does it under the hood. Actually, what it does is it copies the contents out of your existing session, creates a new one, copies the contents over into the new one, and invalidates the old one. But developers aren't going to be able to get that right. We've spent a lot of time figuring out how to get this just right. You can do remember me cookies, and we argued a lot about this. Because a lot of people don't like remember me cookies. But at the end of the day, we decided, you know what, there's an awful lot of sites out there that need this, and we need to show them how to do it correctly. So we're creating an encrypted token as the remember me cookie. It has a timeout, and it also will be invalidated if the user changes their password. In a lot of sites, if you get a remember me cookie and the user changes their password, the remember me cookie is still good, which is a problem. You need to have a way of allowing users to invalidate the remember me cookie. So we've got all that built into the API. Let's talk about access control a little bit. This is a real challenging area for developers, and we see quite a lot of mistakes in this. This isn't the kind of thing that a scanner can find. What we've done in ESAPI is we've provided a number of different methods to allow developers to do access control at the right point in their application so that they, so that they can implement the policy that they're really trying to implement. The first thing is authorized for URL. You probably call this in your controller to check that the user is allowed to access the URL that they've selected. We've got a is authorized for function call that you'd call from your business function. This is a simple check to make sure that the user is authorized for that function. Notice that this is a little different than what's built into Java or the other languages. Most platforms have something like a check that says, is user enroll? Which isn't exactly the simplest thing for the developer. So we see a lot of code that has, if user is enroll manager, and they're logged in from an external connection, and it's Tuesday, and the moon is full, and a whole bunch of Boolean connections, Boolean math to figure out whether a user's authorized. That's complicated. What we're trying to do is encapsulate all of that decision inside an is authorized for kind of function. That way, if you need to change the rules or audit the rules, you don't have to go rooting around through a million lines of code. You can look at how the policy is actually implemented in these methods and verify that it works correctly. So we're really trying to simplify the job for the auditor as well as the developer. So deeper into the application, you need an is authorized for data call. So even if the user is authorized for the URL and the function, maybe they're not allowed to execute it with someone else's data, right? So we need 3 different checks here. There's a few others. You can check if they're authorized for a service or for a file. Underneath the hood, you can set policies about that. And then in the presentation layer, when you generate your web page, you're probably going to want to make a decision about whether the user should see a particular button or link in the web page. For instance, you wouldn't show a user the delete account button unless they have permission to delete an account. So in a lot of web applications, it's separate. The developer implements this check in the presentation layer to show the button, and then got a bunch of code somewhere else in the app where they check permission in the business logic. It's the exact same check. So what we're doing is we're encapsulating it in a single function that you call in both places. That way you don't mess up. The code doesn't get out of sync. Obviously, the worst thing you can do is only make the check in the presentation layer and not make it in the business logic, and we see that pretty often. That would allow an attacker to forge the request with the request for the business function in it and just have it succeed. That's one of the Owasp top 10 access control problems. So we're trying to address that here by making it really easy for developers. Let's talk about direct object references. So this is another one of the Owasp top 10 in the access control area. We see a lot of apps that have URLs like this. File equals report 123.xls. We call this a direct object reference because it's directly referring to the file on the back end. So it's like the developer's handle to this. Well, attackers love this stuff because they want to inject, do ... injection or null byte injection or path manipulation of some other kind to try to manipulate that path name and access some other file. Well, if you're using the actual handle in the URL, you expose yourself to this. So what we want developers to do is to use an indirect object reference. So we've provided this object called an access reference map that does a sort of a translation. The developer can replace the file name with an indirect object reference with a simple call, get indirect object reference, and then translate it back into the direct object reference when they receive the response back. So now they've completely obfuscated the actual file name, and they don't give the attacker any way to attack this. If the attacker changes this to 0 or 5 or blue or a script or something, it's not going to match anything in the map, and so the attacker is just going to get an error message. In fact, ESAPI detects this as an attack, because no one should ever be requesting objects that aren't in the access reference map. So that's one example. Here's another example where people are exposing their database keys. Database key is another kind of direct object reference. And so we can translate those into some kind of indirect object reference, in this case, a random string. So we've got both kinds of indirect of access reference maps here. You can do integers or you can do random strings. There's a few benefits to random strings if you want a little added CSRF protection, but there's no requirement to use either one. Yeah. Is your access map global or is it unique per user? It actually depends on what you want to do. It's just a data structure. You can use it however you want. The most common use case is per user. So if you log on and the user has access to like a dozen files, then you might make an access reference map for them that just has those dozen files, and then you can use those in the presentation layer to generate your UI. You could create a global one if there was a use case for that. I'm not exactly sure what that would be. I can sort of imagine it, but it's kind of like doing your access control check up front. Right? You do the access control check, figure out what the user is allowed to access, and then you generate this access reference map. And then from then on, you just use that. And that makes your access control check really easy.
It's a whitelist.
Yes, it's a whitelist. Exactly. So you don't have to do an access control check, a complicated one on every request. It's sort of, it's like the simplest way to do this, really. But yeah, this is, Jeremiah had many examples in his talk were based on this flaw. Because it's so prevalent on the net. We don't have this best practice out there that people should not expose their direct object references. In fact, someone I know used to call this exposing your privates. He said, never expose your privates, right? That's what this is all about. OK. Now, I want to talk about the error handling and logging and intrusion detection architecture in ESAPI. This is kind of new. Not a lot of web applications have this. Most of the stuff in ESAPI is kind of real best practice, like well understood stuff. We tried to go a little beyond that in ESAPI here. So I'm particularly frustrated by the fact that applications will let you attack them forever. If you're a pen tester, you know this, right? You can beat on an application all day with all kinds of crazy stuff that no legitimate user should ever be sending. And what do you get back from the web application? I didn't understand your input. Could you please try again? We need to detect attacks and stop attackers. When we see them doing stuff that no legitimate user could ever do, we should stop them. So we've got this error handling and intrusion detection architecture built into ESAPI that will help with this. So the first thing we did is we defined something called an enterprise security exception. It's a global class, and then there's a bunch of implementations of that: validation exception, access control exception, authentication exception, encryption exception, and so on. And these take two different messages. One message that's intended for the user, and one message that's intended for the logs. Now, this solves a problem that developers have. Nowadays, if they catch an exception in their code, they can log it with a bunch of details, but then maybe that log message gets up on the user screen and gives them details about how to hack the site. So we don't want that. But at the same time, you don't want to dumb down the message so that you have nothing useful in your logs. Right? You need both messages. And the exception handling mechanism is a simple, easy, obvious way for developers to handle that. So all you have to do in your code anywhere is throw a security exception, and you get both log messages, and you can deal with them where it makes sense in your code. So just by using ESAPI, you get a whole ton of really great log and error messages just by default. Yeah?
Is there an ID provided so the user message is tied to the log message? So when the user calls support and says, I got ID number?
Yeah, absolutely. So remember, see this little guy here? That represents the user object. So I said earlier that the user object is available anywhere in the application. Well, the logger uses it too. Right? So the logger will get the currently logged in user identity and make it part of the log message. So you'll see a detailed message, user whoever did this action at this time, and here's the specific message about what went wrong. So all enterprise security exceptions automatically get logged. So because all the security controls in ESAPI use the logger, you get great log messages. Right? You run an application and you can see all the access control failures, all the input validation failures, all the encryption exceptions, everything like that ends up in the log, which is where you need it. I don't know if any of you have looked at any enterprise application logs, but they don't have a lot of security information in them because developers don't know what to log and they don't know how to log it. So you get a lot of that stuff for free here. The other thing that we do with these exceptions is we send them to an intrusion detector. So now the idea here is very simple. We're feeding a stream of events into this intrusion detector and allowing it to figure out if any of those events represent an attack. The implementation that we have now is very naive. All it does is allow you to set thresholds on different types of exceptions. So you might set a policy like, if I get more than 20 input validation exceptions in a 3-second period, maybe someone's attacking me. Then I can take some kind of response. I can log it, I can log the user out, or I can disable their account. So that simple policy would probably stop every single scanner on the market dead, right? Because when you scan a site, you generate a lot of traffic really fast, and it's going to blow up all, it's going to create a lot of exceptions. So you can stop your application from being scanned with this. And then you can disable the account so that the scanner really can't get back in. There's a lot of different policies that you can set. We're not really sure what the exact set of policies that we want to enforce is. There's a Summer of Code project that's researching this, that's going to put this on some real applications and watch what kinds of thresholds are reasonable for an enterprise application. Then we'll get some good data about what kind of policies we can enforce. But again, this is a very naive implementation. I can imagine somebody plugging in a Bayesian rules engine here and doing some real interesting intrusion detection. We're just trying to prove the concept that intrusion detection inside the application is the way to go. You can't enforce these kind of policies with a standalone intrusion detection box on the wire. You have nowhere near the amount of information that you need in order to detect an attack like this. Okay, so that was my whirlwind tour of ESAPI. Question, yeah.
So is it natively designed for whitelisting so that you can actually say to this legitimate scanner, please don't block? Is it designed for that as well?
Yeah, you could set that up. In the intrusion detector, you could easily create an exception for that. We don't have any configurable policy about that now, but it's certainly a good idea because people do want to scan their own sites. In general, the ESAPI has been built to be everything whitelist. We don't do any kind of blacklisting anywhere. It's all about whitelist enforcement of security. And we think that's a lot simpler. Thanks. Okay, so in terms of coverage, if you look at the Owasp top 10, ESAPI has pretty good coverage over the top 10. Certainly way superior to anything you'll get from a static analysis tool or a scanning kind of tool. This is really about prevention. And so we've got controls that will handle input validation and output encoding, so you'll handle all your cross-site scripting. All the injection kinds of flaws, like command injection and SQL injection, we've got stuff for that. We've got a safe upload feature built into the HTTP utilities. That does a whole bunch of checks on any file that gets uploaded to make sure that the file name is legitimate and the size is right and the storage location for it is right, and all that stuff gets checked. I talked about the access reference map for insecure direct object references. We've got CSRF protection built in. There's got a token system built in, all based on strong crypto under the hood. There's the exception handling stuff so that you get good error messages and good logging. We've got broken authentication in sessions. We've got a lot of stuff in there about authentication and session cookies in particular. So anytime you set a cookie, we can have it set the secure flag and the HTTP only flag on that cookie. So I don't know if you followed the recent discussion of surf jacking. ESAPI's got protection against that kind of attack where people are stealing cookies out of the browser. We've got a nice encryptor that does things like encrypt and decrypt. It's also got hash functions. It's got a secure token generation function and a digital signature and verify function built in. We didn't go crazy here. We were thinking of putting in a bunch of certificate functions, but we realized, most enterprise web applications don't have to do certificate processing today. We may add that sometime in the future, but we're really trying to restrict it to the functions that are used in the vast majority of apps today. We've got some things about insecure communications, but we can't do everything here, right? We're just in the code. We can't do anything to force you to configure SSL in your server, right? So we don't do everything. We do verify that the channel is secure, and we do the secure cookie checks, but we can't do everything here. And then we've got a pretty sophisticated access controller to allow people to enforce that access control throughout the site. Oh, so I just want to point out something about the tools. MITRE did a study a few years ago that looked at all the different tools out there. Steve Christie doesn't like this slide because he doesn't think that this data was intended to be used this way, but I think it's instructive, so sorry, Steve. But if you put together all the claims of all the different tools that are out there and compare it up against the CWE, which has a list of 695 different weaknesses, you'll see that there's only 45% coverage by the tools. That leaves a whole bunch of vulnerabilities that are not covered by the tools. The other thing that they found was that there's not a lot of overlap between the tools. So to get that kind of coverage, you've got to run all of them. It's a pretty expensive way to go. So I'm not down on tools. I actually really like these tools. I've written static analysis tools. I believe in them. But I want to make sure that people understand that the tools are not going to give you the kind of coverage that you need in order to really be secure. You can't scan for the OS top 10, right? Those problems are too complicated to scan for in a lot of cases. So I need people to be aware of that. But I do think that the tools are an important part of a balanced breakfast. Like you should have tools as part of your enterprise application security program. All right, so here's where we are with the ESAPI. So I started thinking about this a long time ago when we started doing this work and we started seeing these problems, and I had this idea, and then I always figured someone would do it, actually. And time went on and no one did it, so I started sketching out an informal API, got a bunch of people together. We started a reference implementation, formed an expert panel, so I got some of the serious researchers in the space and got them on a team and started reviewing the API. Then, I guess almost a year ago, we released the first version of it, and we've been working on it pretty heavily since then. The latest release is 1.3.1. It's got all the functions implemented that you've seen, and we're going to have a summit in December, and we want to get together a relatively small group of people to really come together and bear down on this API and make sure we've got everything right. We want to get a really great API here. We're looking at other languages, so we've got .NET and PHP versions in progress. There's alpha stuff out on the web. Someone's building a classic ASP version, which is really cool, and this company Galwa, which does a lot of work for the NSA on high assurance systems, they're building a version of ESAPI in Haskell, which is a high assurance language. It's a functional language. And I'm really psyched about that. They're actually going to use that in their implementation of multi-level secure web stuff that government is going to use. So I think that's pretty neat stuff. We're also looking at extending into other domains, right? So right now, it's useful in web apps and web services, but I would love to make a similar library, maybe it's with some overlap with this library, that supports developers in other styles of computing, like rich clients and JavaScript, AJAX stuff, that kind of things. Those developers need security functions too, and we need to support them with simple, easy to use, high assurance security components. So if anybody's interested in getting involved, I would love some help in those areas. One challenge is framework integration. So a lot of enterprises use frameworks already. And sometimes there's a conflict between what ESAPI does and what the framework does, and it's not always clear how to integrate those things. Probably the right thing to do here is to go work with the framework folks on integrating ESAPI into their framework so it uses the framework natively. Because trying to wedge them together isn't always perfect. So that's something that we're going to try and do over the next year. The other influence that ESAPI is having is, like I mentioned this morning, we are reaching out to some of the platform providers, and they're adopting little pieces of ESAPI. So the Sun servlet spec, the next version, you'll see some of the work that we've done here reflected in the servlet spec. So it's all open and online. This is all under the BSD license. So it should be very easy for anybody to use this stuff in their organization. BSD license is extremely permissive. You should be able to build it into your apps. Your lawyers won't go crazy. Hopefully, if anybody has any problems with that license, Oracle actually called me up and said, hey, what license are you going to use for this? I said, I don't know. What works for you? They said BSD. We said, OK, great. We'll use BSD. But let me know, because we can offer it under multiple licenses if we need to. The Java doc is extensive for this stuff. We spend a lot of time capturing things in the Java doc. So maybe you're not all bought into ESAPI, but you need to know how to write some little function in Java. Like you need to know how to do HTML entity encoding, right? Look in the Java doc here, because we've specified exactly how we do it. And then you can look in the code to actually see how it's implemented. In terms of assurance, I mentioned we've got a big team that's looked at this stuff. We've built apps. We've pen tested them. We've done code review on the whole thing. We've run all the static analysis tools on this. So we've run Fortify and Ounce on this tool. We've also run Find Bugs and PMD on it to verify that it doesn't have those kinds of problems. We're clean on all of those. We got about 600 JUnit test cases, which all pass. We've got about 89% coverage, which is actually very good. If you're writing enterprise security controls, I strongly suggest that you build some JUnit test cases to make sure they do what you want. And starting with these wouldn't be a bad idea. You'd probably have to tailor them a little bit, but these have a lot of misuse cases in them that will be very useful in testing your security controls. So even independent of the whole library itself, the test cases for the library might be extremely useful to you. Let's see, what else? I think I covered all that. Oh, it is being used by a number of organizations. Sun in particular has already deployed applications using ESAPI. And there's a bunch that I've had private meetings with that I can't talk about, but I'm meeting with a lot of organizations about how they can go about establishing their ESAPI strategy. All right, so I think I've covered the test cases and so on. I'm going to post this presentation on the site. So this is a list of banned Java APIs, things that ESAPI replaces with safe versions. So in your work, you might be interested to know what I think the bad Java calls are. And I want to talk just a little bit about some of the cost savings with ESAPI. They really are across the whole lifecycle. So we're imagining an organization here that's got 1,000 apps. And if you look at the cost savings from requirements all the way through remediation and standards and guidelines, there are cost savings at every stage. I mean, just think about it. Instead of having to teach developers this, you can teach them a small API with 120 methods. Oh, by the way, the whole of ESAPI is about 5,000 lines of code. So it's very easy to dig in and analyze and understand and really have some assurance in. So this isn't the biggest project in the world, even though the scope of it is pretty broad. OK, so before I do a couple questions, I want to do one thing here. I want to show the ESAPI swing set. So we're producing a demonstration application here that will just show off some of the capabilities of ESAPI. And this is available on the website. You can download it and run it in a Java container. But for example, here's one that allows you to accept rich content. This is building on the ESAPI capability. Every one of these has a little tutorial, and then an insecure demo about what can go wrong if you don't do this, and then a secure demo that shows how to do it right using ESAPI. And it's usually like a couple of lines of code with ESAPI. So in this case, we've got some input here that has a cross-site scripting attack. And when we submit it here, sorry, I'm having a little trouble steering. When we submit this, the request comes back, and we've turned it into safe HTML. And you can see here we've stripped out the script. So this will work on any kind of banged up HTML that you want to put in here. We've had a live site testing anti-SAMI for several months where all kinds of researchers have been pouring attacks into it. And it found a very few number of problems, which we did fix. But for the most part, we've been very successful with making sure this is bulletproof. There's a bunch of other exercises here that you can check out. There's, you can see how you log in. It's very simple. I'll go to the secure demo here so you can see the ESAPI login. If I'm going to log in here with, you can't see the box. Oh, there, it was way over there. So it's admin. Password is written up here. It's look at me01 at. ESAPI enforces a strong password policy. So you have to actually, when you set it up, you have to choose a pretty strong password. You can log in and it we'll print out some of the information about who the current user is. ESAPI tracks your last successful login and last failed login and all that stuff that we invented in Unix in 1950 or something, and now most web applications don't do. But a couple of banks are now starting to do this because it's really a smart thing to do. So ESAPI supports that. We've got a logout function that will log you out. It'll kill your cookie. It'll do the right things. So why don't I, I've only got a couple minutes left, so why don't I just go to questions. I'd love to know what you're doing internally with your libraries, or how you see this being used. Let's talk about it. Yeah, in the back.
Okay. The API, this ES API, do you know if there are some vendor out there that would provide support to company that want to use it?
Well, yeah, certainly. I mean, it is open source, so any company that does security consulting could do that. Certainly, my company would be willing to help you, but I'm not here to really try to push my services. I'm happy to help you if you're interested. That wasn't a shill, by the way. I swear to God. I have two hats, right? I'm the CEO of Aspect, and I'm also the chair of Owasp, so I try very hard to keep those separate. So just so you know.
I have a question regarding the maintainability. I guess that if I would suggest going for ESAPI in our projects, my colleagues would say, okay, is it a stable interface? Will we be doing updates? Will everything not build anymore? Or okay?
It's a fair question. I believe the API at this point is fairly stable, but I'm not going to guarantee that it's not going to change because we're dedicated to getting it right. Until we have more enterprise users who are really integrating this into serious enterprise applications, we need to get that feedback before I can say that we're at permanent decade-long API freeze. I can guarantee that it won't change a lot, but it will change if we find something that we need to change to make it easier for developers to use. We're going to have to do it.
Will you change it before PHP makes its next important change?
That's an excellent question. I don't know. We are tracking different languages with this, and we're not hard over on making the ES API for PHP exactly the same as the ES API for Java, right? There may be some calls in the Java API that just don't make sense in PHP, so it'll be similar, but not exactly the same.
My point was that the languages themselves, for the most part, are not particularly static. So.
Yeah, what are you going to do? I mean, we've already got that problem with Java. ES API is designed for Java 1.4 because many enterprises out there are running 1.4. We do have a version for 1.6, but now we're forking. It's not a lot different, but it's a little bit implementation different. Yeah.
Jeff, how many real-life deployed applications currently use ESAPI?
I have no way of knowing that, actually. How many people are running Linux? I mean, you don't know. Okay. I don't think it's that many. I know that there are at least 10, but I don't know. It could be 100. It could be 11. I don't know. Yeah, in the back there's a couple.
Would you consider having a underlying C library that makes it available to many more languages if they choose to use it through some kind of native interface?
Ah, that's a pretty interesting idea. I hadn't really thought about that. Someone from eBay was interested in having a seaport of this stuff. When they got into it, they realized that you know, there's a lot of, you know, like I said, we're built on the shoulders of giants here. So, you know, in order to do ESAPI in 5,000 lines of code, you got to build on top of some pretty powerful stuff that's not available in C, or might take some work. So I think it's a really good idea. Then it would apply to almost any environment. But then you got, you know, multiple platforms to support and all kinds of porting issues. It's not a bad idea, but it's probably outside the scope of something that I can do myself. I need somebody to really champion that.
Yeah, a lot of the prevailing frameworks use declarative authorization and authentication. So does this sort of force you into a more programmatic way of doing it versus, you know?
Not necessarily. It's an excellent question. I think declarative access control is a great idea. In practice, it's got some difficulties. So, you know, I don't see a lot of people using declarative access control in Java, for instance, because it just doesn't really meet the need. But there's no reason that you couldn't use a combination of this with some declarative way of attaching it to methods and business functions and so on. What we're trying to do with ESAPI is provide a fundamental set of security building blocks. And we want to make them really good and really concrete. And then we expect that people will build on top of that. So, you know, a way of compiling it into a program in a declarative way, great, you can build on top of what we've built. But until you have those foundational building blocks in place that are really good and really high assurance, you might as well not try. I mean, we got to have these things.
One question regarding the validators. There are some things that need to be validated, and they turn up in every kind of web systems. And the killer thing is to validate an email address.
Yeah.
So are you planning on having a kind of a library of good validators?
Yeah, there's actually a whole set of good validators built in. They're all configurable. So they go in that ESAPI properties file by that security configuration block. So it makes it very easy to add new types to your validator. So if you want to declare a validator for your company ID, you can very easily declare that as a regex in the file and then use it very easily throughout the code. So we've tried to make it data-driven. The validator is all data-driven.
For access control and the user management piece, what existing enterprise systems can we hook into, for example, for single sign-on, for other existing systems? Can we tap into those, for example, and not use the login, logout functionality and still have access to the user object in the other objects?
Right. So it's an excellent question. You can use any enterprise authentication or access control system. You would need to customize the implementation of the access controller API and the authenticator API, but you can tie it in. So right now, there's a text file-based authenticator and a text file-based access control system, and they're sort of intended as demonstrations. Someone's built a MySQL-based authenticator implementation, so you can go to a back-end database and get those things. It'd be very easy to build an LDAP version of the authenticator to go to your Enterprise Active Directory or whatever. But the idea is that you have to customize those things because every company in here has a separate, different access control and authentication system.
So it should be easy to even tie into, say, externalized authorization systems that are centrally managed with central policies.
Absolutely. You could even invoke a web service. The point is we're trying to make the API exposed to the developer super easy so they don't have to think about it, what happens under the hood.
What's the learning curve for average Java developer with no AppSec background?
Wow, I don't know. We've tried really hard to make this API completely obvious for developers, even if they don't know a lot about security. So for instance, most systems that you look at today have a method called HTML encode or HTML escape or something like that. But think about that function name. It doesn't tell you when to use it. Right? So in ESAPI, that same method is called encode for HTML or encode for HTML attribute or encode for JavaScript. And the idea is we're trying to, we've worked hard on the method names to try to make them really obvious for developers about when to use them. I think you still need that coding guideline to tell developers when to use it, but we've tried really hard to simplify it. Personally, I think it's really simple to use, but I've been doing this for a long time, so I'm really not the best person to judge that.
So what would you recommend if I want all developers in my company to start using this? I mean, where do they start?
I think the best thing to do would be to look at the API and then compare it against what you already have in your enterprise. So you may have a logging library that you use or a crypto library that you already use, and you might want to think about, where are the gaps in what we've got? And then, what I want you to do is a little work up front and think about what your enterprise security API looks like. And then once you've decided on that, then you need to just proliferate it. Use whatever mechanisms you normally use. I think it's probably a standard that you put out, like a guideline, and then start getting developers to actually do it.
We have time for about 2 more questions, so if you guys want to ask some more.
What sort of problems have you seen with integrating with Struts, Spring, other application frameworks that people might be using?
Sure. So Struts has a validator already, right? And so there's a conflict there. Which one are you going to use? The one that's in Struts is already used. Like in validator form, it automatically invokes the Struts validator. And so you configure the policy in validation.xml, and then it enforces it, right? So there's no hook in there to say, oh, go off and call this other validation library in the right place, right? So those are the kind of things that cause an issue. You could just not use the Struts validation stuff. If you just use regular action form and then invoke this, you'd be fine. But I think it would be better if we work with Struts and Spring and Rails and all the others to use these fundamental building blocks under the hood and make them invisible to developers, right? Like we've talked about doing some higher level stuff, like we could validate the whole HTTP request in one place altogether, but we haven't. We've kept it at the sort of the fundamental building block level because we want frameworks to adopt this and build it into their stuff.
Great, 1 more question.
Hi, you alluded to Pascal and the government. Have you had any dialogue with the defense contracting industry in general, their security standards and their interest?
Yeah, it's interesting. So, I've talked to a bunch of government contractors. I've talked to a bunch of government agencies. In fact, my experience with government agencies started back in about 2002. I was talking to a lot of them about application security in that time frame, and I was getting really frustrated because basically the answer I was getting was, yeah, I think I sort of understand what you're talking about with this application security stuff, but we're working on the SANS top 20. And I got frustrated with that, and I went home and I said, wow, you know what? It would be great if we had a top 10. And then this light went on. And so Dave Wickers and I wrote the first version of the Owasp top 10 and put it out there, and it took off and got a lot of people interested in application security. And so my experience with government has actually not been that great. I've been participating in the DHS software assurance forums for quite a while. I'm talking at the one coming up in a month or so about ESAPI. So there's interest, but I think they're well behind the financial industry in terms of how far along they are in terms of thinking about application security.
Last extra credit question.
Yeah.
Are there going to be integration points for things like SAML and Kerberos?
Yeah. So Gunnar Peterson has been beating me up quite a bit about that, like OpenID and SAML and XACML and all those different things. Some of those, I think, would make great implementations of the API. Right? So for instance, if you wanted to specify your access control policy in XACML, great. You build an access controller implementation that looks at the XACML policy and enforces it. So that kind of thing is reasonable. I think there's some work to be done there. I think it's important, but I'm not sure. We were really trying to make a library that developers could use today to solve the problems that they have in front of them today. So one of the big use cases of this is for remediation, right? Developer gets a report that says, oh crap, I got 300 cross-site scriptings in my application. I want them to be able to take the ESAPI jar, throw it in their lib directory, and wrap a few calls with the appropriate ESAPI call, recompile, and go. That's the kind of use case we're looking for. We're not quite there, but that's the ongoing work here, is to figure out how to extend and use some of those newer technologies. All right, well, thank you very much, everyone. I really appreciate it.
Thanks, everybody, and thanks, Jeff. And we'll be